Jimmy. So my name is Tin. I'm a PhD student at Porsche AG and a tech lead for data for foundation models for autonomous driving. And today we will present our latest research, which is a benchmark for evaluating foundation models in the task of vision language navigation. So foundation models have already become an integral part of our society in the web context. They are able to generate text, emails, code, and even images and videos for us. And through large-scale pre-training on the web context and the large context window we can pass by the sequence, we get very targeted output sequences for our input sequences. Through reasoning, they are also able to break down larger problems into smaller sub-problems, which makes them also able to, in the latest research, also solve more complex tasks. However, apart from the web context, these models still did not find the way to the physical world. And latest research also deals with the connection, lifting the capabilities of foundation models to the physical world, which is known as vision language action models or embodied AI. But what is the value proposal behind it? So first of all, these models promise to be able to generalize on the large context of the open world, to generalize on multiple scenarios, regardless of the embodiment or the task they have to solve. Also, they allow us to interact through language or through mimics and gestics in the future, which is a very intuitive way of interaction with embodied agents. And thus, we are able to have very interesting new experiences in the real world with embodied agents. Additionally, they are configurable. Imagine a robot in the factory, and you can configure it by prompting it, by telling it what to do in natural language, instead of having to provide code or some script language for the robot. But what do these so in terms of autonomous driving, we can rethink autonomous driving and create agents, embodied agents as interactive drivers or co-drivers. I don't know how many of you know the series Knight Rider. For me, it was only a morning series when I had serials before school. But Knight Rider is exactly what we want to achieve. We want to have cars which interact with the driver and understand the environment and can take actions in the environment. But what are the capabilities needed? In prior works, we have created a systemated framework for the area of vision language navigation. So how can we systematize the area of vision language navigation for autonomous driving? And we have defined 4 pillars, which is the context. This is the physical world. Everything which can happen in the physical world, all the scenarios, the rules and the values applying to the physical world. The modalities, which can be seen as the senses with which the embodied agents can understand the physical world. For instance, cameras, lidars, language, and other modalities which are available. Like we humans have nose, we have eyes, we have ears to perceive the environment. And then these models need to have certain capabilities, and these capabilities are inside the functional chain of the vehicle in order to fulfill certain downstream tasks. And these tasks can, for instance, be driving, like acting in the real world, or answering questions of the driver. In order to understand what the actual capabilities are, we derived capabilities with which human agents need to interact with the physical world. So what do humans have to be able of in order to interact with each other or to interact with other entities of the real world? And for this, we derived 4 major categories. The first one is semantic understanding. So we need to understand objects, their classes and attributes and affordances. Spatial understanding, which is the location, the quantitative distance between things, the orientation of things towards each other and towards the agent. Temporal understanding, which is the evolvement and development over time, for instance, a trajectory of a vehicle in the past and also in the future. And physical understanding, which is the rules applied to the real world and the constraints, for instance, gravity or dynamics or forces, which are providing rules and constraints to understand the physical world. In very explicit context, this can be, for instance, driving dynamics for an autonomous vehicle. And based on these capabilities, we evaluated current benchmarks. Can we evaluate these capabilities in a generalized context for vision language action models? Can we evaluate vision language navigation with current benchmarks? And I won't go into detail with this very large table, but what we found out is that generally most of these benchmarks are not closed loop, they are open loop, which means that there is no evaluation of interaction of agents. And there's a paper which is ego status all you need for open loop end-to-end autonomous driving? And it questions the feasibility for evaluating actions in the real world through open loop benchmarks. But this is only the least important part which is missing. The second one is that there's no capability-centric assessment. So most of these benchmarks are vision question answering benchmarks, which try to ask questions, general questions about the context and the environment. And when we look at our 4 capabilities, there's no separate evaluation of them. Some of these benchmarks implicitly also include, for instance, spatial questions or some temporal questions, but none of these really evaluates those models on those 4 separate capabilities. And the most important part is that there's no driving assessment done based on the driver instructions, based on the prompts. For instance, if I tell my vision language action model what to do in the environment, if I tell it turn right on the next intersection, there's no mapping, no scoring of if this model fulfills my prompt in the environment. And therefore, we created a benchmark which tries to address these shortcomings of current benchmark by evaluating those 4 capabilities separately in 2 stages. In the first stage, there's a reference agent which drives in the environment, and this is what we took over from Carla, and can assess certain ground truth and ask questions to the agent. The agent has to answer those questions, and in the next stage, it has to navigate the scenario by fulfilling certain prompts. These prompts are mapped in each scenario, and each prompt can be evaluated separately in the accordance with the prompt. So the semantic questions are mostly about classes, about their attributes and affordances. For instance, a car can open the door. Attributes are if the car has a certain color or if there are certain colored objects. And classes are, for instance, if there's a construction site or is there which cars are there some other objects in the scene. Spatial questions are mainly about the count of objects, the qualitative positions and directions of objects, and quantitatively about the relative distances between objects and also the distances to the ego vehicle. Temporal questions are mostly related to state changes. They are posed in some long-term timeframes and short-term timeframes to assess also memory of those models. And they are also mapped to certain movement descriptions, for instance, certain maneuvers over time, which have to be inferred from the temporal context. Physical questions are mostly related to the physical rules of the environment. And we also ask the models to calculate certain parameters for driving, for instance, the brake path or some other driving dynamics related information. Also, we do reachability analysis as a ground truth and provide it for the question answering so that the model has to answer which models even can even reach the vehicle with their physical properties. And all of these things together pose the visual question answering, and now most importantly, the action part. For the action part, we separate each scenarios to certain maneuvers, and it starts with atomic maneuvers. So the model has to adhere to certain prompts like accelerate, decelerate, steer, which are quite simple prompts. Then it becomes more complex, and we also ask lane changes, lane keeping, and object following. And the complexity increases over the whole scenario. For instance, when we ask the model to leave the highway, like you see in this video, and turn left, or cross the intersection, or leave the circular traffic at a certain exit, like the third exit or the second exit. And we evaluated certain baseline models within the benchmark. So many of them are not driving related models, and some of them are driving related models fine-tuned on specific data sets, like for instance, the new CQA with Drive or Dolphins. And what we found out that these models are really good at semantic understanding. So they understand basic classes, basic attributes of classes, but they do not understand space, time, and physics well. And this manifests in the driving, whereas these models currently cannot navigate in the environment. Maybe they can beat a certain benchmark, on which they are fine-tuned, like when it comes to the driving-related models, but they cannot generalize and act in the environment according to our benchmark. So in the future, what this implies is that if we want to have embodied agents which can interact with the environment and the driver for vision language navigation, we would need to improve those models on the spatial, temporal, and physical domain in order to be able to navigate the environment. You can see it in a very simple example qualitatively here. So I asked ChatGPT, what is the nearest model? And you see that it will not give the right answer from the image alone. For us as humans, it's quite simple, even with our very simple stereo vision, to understand what object is nearer. But in this case, it will not answer the right question for the spatial domain. So what we see is that while semantics, due to the large web context on these models, or on which these models are pre-trained, is captured well, while the other 4 capability dimensions still need a lot of improvement. So what we want to do next, we want to even more elaborate on the generalizability of models. We want to add more general questions. We want to add more domain shifts between specific scenarios, for instance, integrate parking scenarios or new driving scenarios. Also, we want to assess different embodiments, for instance, SUVs or sports cars with different sensor sets. And we want to integrate this emphasis on generalization ability inside the benchmark more. So we currently work on that, and the next version of the benchmark will also allow these kind of generalization assessments. We also want to optimize runtime for the question answering and the actions. So we already observed we have a very large amount of questions derived from the Carla leaderboard challenge. We construct our benchmark and create variations from them. And we observed that we have a large amount of scenarios, and we want to reduce the scenario so that it's feasible to run, so quality over quantity, to run over a certain period of time, many models, so that the research community can easily access the benchmark and can run it even on a local computer, which does not take so much time. So in our evaluations, each model took a lot of time, and it took almost a day for each model to evaluate on this benchmark because of the large amounts of questions and answers generated. And also we want to assess if we can integrate real data, so not only synthetic data from Carla, but also real scenarios, and integrate them into the benchmark so that the generalization ability is even evaluated more thoroughly. And apart from that, we are currently developing vision language action models for vision language navigation and autonomous driving. And these models will have all of those 4 capabilities covered. And we will keep you updated in shortly about that, and hopefully in the next conferences. Thank you very much. I hope you enjoyed the talk. And the Drive4C benchmark is available open source on our GitHub page. So you can scan the QR code and also evaluate your models based on those capabilities and on vision language navigation prompts. And give us feedback. We appreciate it. We hope that in the future we will see models which are able to navigate in the real world and are excited about the next developments. If you have any questions, feel free to ask. Thank you very much.